Okay, now, we're getting some interesting results in this quiz. First of all, I say find the x-intercepts. What's the logic behind finding the x-intercepts? Because what people have done is typically they've just started plugging numbers into the quadratic formula, and it's not clear that everybody sees the connection. So make sure you understand this, that x-intercepts. Let's put a y equals over here. When y equals 0, because y equals 0 everywhere on the x-axis. And this is a big deal. And people seem not, I mean, this is universal in pre-calculus classes. People just don't seem to want to understand this. Well, I think they want to understand it. For some reason, they find it difficult to understand, okay? So I'm going to put a big star here. This is something you really want to focus on and think about until you really understand it. Because it applies to every function you're going to see in this course. And if you don't know that the x-intercept occurs when y equals 0, when I ask for the x-intercept, you might not know what to do, okay? So. Okay. Now, y equals this. If y equals 0, this equals 0. Well, I'll just switch sides so it looks more like something we want to use a quadratic formula with. But I think you could use it in either form. So that get this, and I think everybody had that. Okay, so I'm real happy to do that. Just make sure you know why you're doing it. You're doing it so you can find the x-intercepts, because the x-intercepts are when y equals 0. And y equals 0 means this equals 0. Okay, so, well, we get 12 plus or minus the square root. Now, I'm just going to kind of do this in my head. This is 144, and this is going to be positive. It's going to be 192. 144 and 192 is 336. Get that right? And that'll be divided by 4. And if 336 isn't right, fix it. Okay? Get it in my head, did it kind of quick, but I just kind of double checked it. I think maybe it's right. So this is okay. Now, (324) is 18 squared, 19 squared is 361. That's only 12 from, so I'm thinking this has to be about 18.3. I don't think it's 18.2, and I don't think it's 18.4, but it might be one of those. 18.3 over 4 is 4.6 approximately. Okay. 4.575. We'll just round that up to 4.6. And that equals 7.6 or negative 1.6. Now, you know how to use a quadratic formula. Do those agree with the numbers you got? Mm-hmm. Good. Okay. So now we know something about the graph. we know that we have the 7.6 zeros on the graph because these are the numbers that make y equal to 0. And the x-axis is where y equals 0. You really have to understand all that. Otherwise, you're just kind of working by habit. And, habit is good. You want to have the right habits. But if you get on the test and your habits don't kick in, you want to be able to reason it out. Okay? And you want to understand it at that level in any case, not just for tests. Okay? So we have zeros, or the x-intercepts. We call these zeros. Number negative 1.6 and 7.6 is a 0. Negative 1.60, 7.60 are intercepts. Now, the second thing was find the y-intercepts. Now, nothing we've done so far is going to be useful for finding the y-intercepts, but it's very, very useful because we've already got a pretty good idea that the graph is either going to look like this or this. Now, maybe it's wide, maybe it's real narrow and steep. We don't know yet, but once we find the y-intercept, we're going to know. We're going to have a pretty good idea what this graph looks like. Okay, so what's the y-intercept? Y-intercept occurs when x equals 0. So we take our y equals 2x squared minus 12x minus 24, plug in 0 for x. Okay, we get y equals negative 24. So the y-intercept is at 0, negative 24. Okay, now where is negative 24 on the y-axis? Well, it's wherever you want to put it. You don't have to have the same scale on the x-axis as the y-axis. Sometimes your numbers for the y values are in the millions, where your numbers for the x values are in single digits. You can't have the same scale on both axes every time. So we just put, okay, you know what I'm going to do? I'm going to draw a parabola through these points, and wherever it goes through the y-axis, that's going to be negative 24. Now, think about it. I can draw the parabola so that it opens upward, or I can draw it upside down. How do I know which way to draw it? Again, if we draw the parabola upside down, then the y-intercept is going to be maybe here, above the x-axis. And it can't be, because we've already determined that the y-intercept is at y equals negative 24. So that's one reason we don't draw the thing upside down. Another reason, sufficient reason, is we have a positive number in front of x squared. Now, whatever this number is, that's going to be the vertical stretch of our toolkit function if we're going to construct this from a toolkit function, which is what we're going to do, okay? But right now, we're constructing it just from the information we can get using the quadratic formula and a few other things, okay? So for two reasons, we don't draw it upside down. We draw it right side up. That's a pretty good parabola. It's better than my average anyway. Okay. There it is. Now, where's negative 24? It's here. So to emphasize that, I'm going to draw a horizontal line through that point and call that line y equals negative 24. So now we've got a scale. 24 is this big. Now, can you estimate? So that we've done step 3. We've sketched the parabola. Can you estimate the coordinates of the vertex from that graph? Well, sketch your own graph, scale it as you wish, but estimate the coordinates of the vertex. Now, of course, we can calculate the coordinates of the vertex. We want to estimate it and see then if your calculation makes sense. Okay, now, as I say, everybody has done this. I kind of had to, I'm sorry, everybody has, everybody's done this. A lot of people had not done this because, again, you start x-intercept when y equals 0, y-intercept when x equals 0, and make sure you understand that and can explain that in terms of the graph. The big old star on that statement. Now, one thing I did that I didn't see very many people doing, and maybe because it's a little hard to see from back there, so I'm going to do it a little more boldly. I've got the line y equals negative 24 here. Okay, that's the line through the y-intercept, the horizontal line through the y-intercept. Y is negative 24 all everywhere on this line. Now the vertex, and I think everybody's got an estimate of the vertex by now. The vertex is here. So I'm going to draw a vertical line through the vertex and see what I think x is. Well, the way I've got it drawn, x looks like it's about halfway between 0 and 7.6. Let's see, is it really halfway? It's a little less than halfway. So I'm going to say x equals half of 7.6 would be 3.8. I'm going to say x equals 3.5. Now it's not going to be accurate, and we've actually calculated it, but we haven't recognized it yet. But x equals 3.5 that's the x coordinate of the vertex as I estimate it from my hand sketch drawing. I expect it'll be reasonably close because I did a reasonably good parabola. When I look at it from here, it looks really good. When I get over here and look at it head on, it's a little few. Okay. So, you know, I probably need to practice drawing parabolas, but I've been doing it for a long time. Probably not going to get a lot better at it. Okay, so x equals 3.5 here. Now, what is y here? Well, from here to here is 24, right? From here to here, is this half of this distance? Is the distance between the horizontal line and the vertex as much as half of the distance from the x-axis down to the purple line? Because if so, if this is half of this, then this is going to be 12 lower than negative 24. Now I can always, you know, subdivide things a little bit. I could divide 24 in half, and I could get like, here's negative 12. Divide that in half, I've got negative 6 here. And then make a couple more marks. If I go to negative 12 down here, well, that would be negative 36. If I go this distance below, that's probably too far. And, you know, negative 18 might be about here. I'm writing those things small, but, you know, I can use that interval 24 and divide it up somehow to get an estimate of how far this is below. I can write a scale on my y-axis based on this estimate. Doesn't have to be a totally accurate scale. According to my scale, it looks like on this line, on the horizontal line through the vertex, y is approximately equal to -30. Okay. Now, see what your estimates are. Okay, so my estimate of the vertex is that it's at the point 3.5, -30. That looks like a 36, I think, very well. Okay, and other people's estimates, we had, I think, -26, -28, and -31. So your graphs are very consistent with mine, and I'm just relieved that mine is consistent with yours. And the x-coordinate of vertex estimates were 2.8, and I think 3 and 3.5, something like that. Okay. So, or 2.6, 2.8, 3.5. Anyhow, or 3.6. There's a 3.6 estimate. So my 3.5 is in the range, maybe a little heavy in this side. And I think maybe my skewness has it a little bit in the high side. Okay. Well, it turns out that we can calculate the y-intercept. The x-coordinate of the vertex because it's on the axis of symmetry. So as we did last time, we can do the -1.6 and add to the 7.6. And it's 3. Okay. Here we average the x-intercepts because, as we said last time, the vertex or the axis of symmetry has to be halfway between the x-intercepts. Otherwise, it would be symmetric right and left. Okay, so this is x equals 3. Now, another way of saying that x equals 3 is to say that the axis of symmetry sits right here in the quadratic formula. It's -b divided by 2a. And a couple of you, I think, actually, I think maybe a majority of the class were using that -b over 2a thing. Because we did it last time, it'd be a natural thing to do. Now, when you were doing that, you weren't doing what I asked you to, which is estimate the coordinates. Okay. But you were doing a good thing. Okay. That wasn't great that you weren't exactly following the directions because there's a reason I asked you to do it this way. But still, if you remembered that, that's very good. Okay. And the axis of symmetry is here, which means it's here, which means it's here. which means this is it. So when we did the quadratic formula, where there's the axis of symmetry, the fact that this, the x-intercepts are at 0 plus 4.6, or at 3 plus 4.6, and at 3 minus 4.6 means 3 is halfway between. Halfway between 3 plus this number and 3 minus this number is always just 3. So here is your axis of symmetry. And it's at x equals 3. And that's then at negative b over 2a, because in the quadratic formula, this is negative b and this is 2a. And I think you're familiar with that. Okay, so how are you going to calculate the y-coordinate of the vertex? You've got the x-coordinate of the vertex. How do you get the y-coordinate? Okay, now we're having a little hang up here. How are we going to find the y-coordinate of the vertex? Okay. And I said, well, you're given the x-coordinate of the vertex. What are you going to do to find the y-coordinate? And nobody could answer me. Okay. Now, if you all who are a cut above the average so far in the pre-calculus class, sometimes a pretty big cut, are having trouble answering that, that means that I know that there's something that people just are not understanding, okay, about these functions. So I say, well, how would you find the point on this graph with x equals 6? Well, you're thinking about a lot of things. You're sorting out a lot of things. There's an obvious answer, and of course we've gotten to it, but couldn't do that. Couldn't give me a good answer to that. Yeah, while we're working in this context. Then I said, okay, well, what if you had y equals x squared, and you wanted to find the point where x equals 3? People aren't understanding that language. And you really need to understand that language. Other things I notice is people are drawing these horizontal and vertical lines and labeling them, even though I've been doing it all along. Okay, there's a point to it, and it reinforces stuff that you still are developing an understanding of as far as graphs are concerned. Okay, so these are important things. Well, we finally got to it. Said, well, if you got y equals x squared and you want to find the point where x equals 3, it took a little discussion, but then so you came around with the realization, well, yeah, you just plug in x equals 3. Okay, yeah, you get y equals 3 squared, that's 9. So on the graph of the y equals x squared function, the point for x equals 3 is 3, 9. You get the y coordinate by plugging in the x coordinate. That's what this rule tells you, right? So if you know the x coordinate of a point, you can always find the y coordinate. Okay. And if you know the y coordinate, you can plug in for y and solve the equation that you get. Okay. And of course, we started out early in the class with, okay, given the x coordinate, estimate the y coordinate, given the y coordinate, estimate the x coordinate. Okay. Now we're learning to calculate. If I give you the x coordinate, you can calculate the y coordinate. If I give you the y coordinate, you can calculate the x coordinate. Well, enough discussion. Well, negative b over 2a is negative 12, the negative of negative 12 over 2 times 2, which is 3. Okay, Now, this agrees with this, as it must. And it goes back to the fact that these numbers are just -3 plus this, -3 minus this. So when I average the two numbers, I'd better be getting -3. And we need to try to understand that about numbers. And then we got this formula that gives us the x vertex. It has to agree with this. Okay. Now, if you got some round off error up here, it might not agree completely, but it's going to agree to as many significant figures as you're using. Okay. Well, in any case, x coordinate of the graph is a point where x equals 3. At that point, what does y equal? Well, y equals what you get when you plug in 3. I don't have room to write the whole expression. So I'm just going to write y equals f of 3. And if you plug in 3, because f of 3 means plug in 3 for x, we're going to get what? 18 here and -36 and -24. Okay, that's 18 minus 60, which is, and that minus 60 is 36 and 24. Yeah, that's -60. You add 18 to that, you get -42. Unless I've got my arithmetic wrong. That's -36. Actually, it's -18 and -24. Yeah. So I don't know what we did, but we kind of screwed that up because our y-intercepts weren't anywhere close to what they should have been. I don't think my parabola is too flat. Okay, so would expect to get something a little closer than that, like -32 maybe. But I don't see where my mental arithmetic is wrong. So check my mental arithmetic here. That's so far off that I'm still suspicious of it, even though I've done it 2 or 3 different ways. I've done it in my head. So the vertex is -3, -42. Not happy about that, but okay, there it is. I'm still not sure I believe it. It can be checked out. You know how to check it. We're not going to take the time to do that. Yeah, so maybe signaling 0. X coordinate was 0 here. We move this thing 3 units this way and dropped it down way down 42 units. Okay. So what's the x coordinate of this point? Well, that point's the vertex of the transformed graph. That point's got to be 3, -42. What's the x coordinate? 3. Okay. So this point is, this line here is x equals 3. What about this dotted line? X equals what? Close, not quite. Yeah. Okay. This rectangle is, okay. Yeah, we're recording. This rectangle is 4 units wide, and this line's in the middle, which means you got 2 units from here to here. If x equals 3 here, then x is equal to 5 here. And if x equals 3 here, you go 2 units this way, x equals what? In this line. That's 5 over here. You're going 2 units to the left from x equals 3. What do you get? 1. Okay. So now I could sketch my parabola. I have a point here, point, oops, here, point down here, and a point here, and a point here, and a point here. And to get my hand out of the way, maybe I can draw the thing, but probably not. Okay, badly drawn, but there it is. Okay. I can figure out what the coordinates of these points are. If the coordinate of the vertex is 3, -42, I know how far I've got to go up and over to get to each of these points, so I can figure out all the coordinates. Now, my question is, what's the function that represents this graph? Okay. This is going to be graph of y equals 2f of x, or f of x is the toolkit sparring function. What's the graph of this? Well, this is y equals a f of x minus h plus k, which equals a is 2, x minus h is 3 because you move 3 units in the x direction, and k is -42. This is what you call the vertex form. Okay, now section 1 of chapter 3 pulls all that together. Okay.